Now you may remember when we talked about critical points, we said a critical point, of course, where the function either has a derivative of 0 or a point where the derivative is undefined. We didn't say at the time whether that point would be a maximum or a minimum. Both max and min have to occur at critical points, but if you know a point is a critical point, and even if you're guaranteed that there's an extremum at that point, you don't necessarily know is it a minimum or a maximum. And so now we're going to talk about ways to distinguish whether a critical point is a min or a max or neither. And so the first derivative test looks at the slope. So suppose we have a function f of x, it's continuous at x equals c and has a critical point there. And so this can mean either that the derivative is 0 there, or even though the function is continuous, that it's not differentiable there. Either one of those could result in a critical point. Well, one of three things is going to happen in the region of that. So if we look at the sign of f prime, if the sign of f prime goes from positive, and then we have the critical point, and then after that it's negative, well then, if increasing and then after that decreasing, that means we are definitely dealing with a maximum. If the sign of f of x crosses from decreasing, then critical point, then increasing, well, it's going down, then it hits that critical point, then it comes back up on the other side. That means it must be a minimum. And finally, if the sign doesn't change, if we have positive on both sides or negative on both sides, then it is neither a min or a max. Then it's some other special case. It is a critical point, and the slope may be 0 or the slope may be undefined, but for whatever reason, it's neither a minimum nor a maximum. So a couple examples quickly. If we have the function y equals x to the fourth, well, let's take the derivative. Derivative of this, y prime equals 4x cubed. And of course, if we set that equal, we'd find that at x equals 0, there is a critical point. And so if we look at what's happening to the sign of f prime around 0, well, if you cube a positive number, you get a positive. If you cube a negative number, you get a negative. So it's negative to the left of the critical point and positive to the right of the critical point. Well, this means it's decreasing to 0 and then increasing after 0, so 0 must be a minimum of this particular function. Look at another example, y equals x cubed. Take a derivative of this, y prime equals 3x squared. Now if we look at the sign of this y prime, this also has a critical point of 0. Well, if we plug in a positive number, square a positive number, you get a positive. Put in a negative number, square a negative number, you also get a positive. And so what we see is that the function is increasing on both sides of the critical point. And in fact, what you get when you have a cubic function is something like this. The function increases, then it momentarily has a slope of 0 right at the origin, and then it increases after that. And so indeed this is a critical point because the slope is 0, but this is neither a maximum or a minimum. This is an example of how to apply the first derivative test.